Hi, in this video we will be going through some of the most common problems that our beta testing are reporting. Our beta testing are using this, which is a prototypical version of the hardware, the same that we have been using here in our lab to develop and test the system. This version, of course, comes with many drawbacks and is, of course, error prone. And one of the most common problems our beta testing are reporting is the buck converter being burned down. This means that this little chip, which is in charge of collecting the voltage from the battery of the power source and then converting it to the appropriate voltage to redistribute it inside of the hub and to all the system, gets normally broken. So in this video we will see how we can sidestep this problem by using the alternative power source of the hub, which comes directly from the Raspberry Pi. Okay, so I got this hub. This hub, let me center it, has indeed one of these buck converters burned down. By the way, let me just clarify that this, as I said, is prototypical soft hardware, and these problems are of course being worked on. The next generation of Chordata hardware will have a completely redesigned power source and power distribution system, and of course this problem will completely go away on the next generation. But by now some of the beta testing already have this hardware at home, and it is a good idea to see how we can use it even if the buck converter is burned. Okay, so first of all, I would like to troubleshoot this buck converter. I also have a working one here. In order to start troubleshooting it, I will use a normal power bank, and I will connect both of them to the power bank. Okay, as you can see, I don't know if it's clear, let me turn off a light. This hub, this buck converter, went down in a particularly problematic way because it is delivering current, but it's delivering 5 volts, directly 5 volts. You can tell because the LED is slightly brighter. I don't know if you can tell it in the camera, but I can see it. So let's check what's happening here. I will unplug it. In order to troubleshoot this part of this problem, you will need a multimeter like this one. If you don't have a professional multimeter like this, you can also buy a cheap one which costs around 10 euros and it will be completely fine for this job. So I can put the multimeter in voltage, and I have 2 probes. In order to measure the voltage delivered by the buck converter, let me zoom in a little. Hope you can see it. You have to place your black probe here in the test point 7, which is a reference to ground, and your red probe can be placed on this bias, which is next to the LED. Hope you can see it. Okay, so I will now power the hub. Let me zoom out. Okay, as you can see, this hub is delivering 5 volts. This is not good. Let us dive into how we can use the alternative power source, okay? So the first thing to notice here is that there is, let me see if you get to see it, there is this jumper, which can be set like this, or like this. The first position is the one choosing the internal power source, so this buck converting, which is now burned down. If I put it this other position, it will be choosing the Raspberry power source, which is the one that we will have to use now. Okay, so let's start by plugging the jumpers that we will use to connect to the Raspberry. I like to have a minimal color coding on this jumpers, so I get to connect everything properly. The black one will be ground, the red and yellow one will be 3.3 volts coming from the Raspberry, and these two, green and blue, will be using for the data bus. Okay, so let's start by connecting the first black one, the first 3.3 volts to the hub. Then we can have a reference of all this on the wiki. This is what I'm following. The black one goes to the second pin, and the yellow one goes to the third pin, like this. After these ones, I can plug the data lines, like this. Okay? Red, black, yellow, blue and green. Okay? Now we can plug the other ends of these connectors, to these jumpers, to the Raspberry. The Raspberry is kind of more tricky because it has a lot of pins and they are numbered in rows. So this one is the first pin of the Raspberry, this is the second one, this is the third, and so on. So we will first of all go search for the ground pin, which is the number 6, and we will connect the black jumper to it. Okay? Notice this is the third column on the second row. We can now connect the 3.2 volt, which is the first pin of the Raspberry, and we can also, this is one of the trickiest, because the other 3.3 volt pin is on the pin 17. So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is the one. Okay? I counted in rows. Okay? The first one, the second one. Okay. And then we will have to plug the data lines, which are easier because they are next to the ground and 3.3 volt lines. Okay, so this is the configuration, the complete configuration I need. Let me zoom out a little. Okay, now I can double check this connector is in the correct position and plug the Raspberry. As you can see, the LEDs on the Raspberry are blinking and this LED lit up correctly, and I will now measure again the voltage on the hub. I will use the test point 7 as a reference to ground, and this bias close to the, must be doing something. Okay, I'm missing the test point. Okay, as you can see, 3.2 volts. So we can already use this hub as we normally do with the other power source, and it will have a correct voltage. That's all for this video, and I will be doing a second video in which I show you how to solve another of the most common problems of our beta testing are facing, which is that some of the K-ceptors, when they are connected in long branches, are not read properly. This is mostly due to the cables we deliver with these beta testing programs, and I will show you how, using a different kind of cables, these problems tend to disappear.